right? Next, let's see the coal-based combined cycle power plants. In coal-based combined power plant, the coal is a low-grade fuels compared to the oil and natural gases. But in reserves of coal are very large. Reserves the coals are very large. Much effort has been devoted to developing clean coal technologies to reduce harmful emissions such as SOx and NOx, isn't it? And successful usage of coals for combined cycle power plant generation necessitated the development of firing systems whose products of combustion whose product of combustions having the number one, the sufficiently low concentration of particulates to reduce erosion and ensure a satisfactory life of gas turbine power plants, and second, sufficiently low concentration of pollutant gases and particulates in the exhaust to satisfy environmental regulation relating to discharging from power plants. Okay, so here one more thing is there. To reduce the concentration particulates in products of combustion before entering the gas turbine, and the hot cleanup systems like multi-cyclones ceramic filters should be developed. Here the control the emission of excess of sulfur and nitrogen, different techniques like low NOx burners, staged combustion, and the flue gas scrubbing. Okay, these are will be used in the systems, and should be used in the systems. The following two dominant coal-based technologies are here I have shown. The first one is the pressurized fluidized bed combustion systems. I mean the PFBC, shortly called as PFBC systems, and in which may be either a bubbling fluidized or circulated fluidized bed system will be used. Okay. Next one, the integrated gasified combustion cycles like IGCC. See, let's see PFBC based combined cycles. Here in these systems supplies hot gases at reverted pressure to gas turbine via hot gas cleanup systems, and the coal and the limestones are supplied to the pressurized combustor, and the limestone is used as the bed material to absorb the sulfur. Mainly it is used for absorb the sulfur. Okay, then the cooling tubes immersed in the fluidized bed are used to generate steam, which is supplied to steam turbine, right? And the combustion products leaving the combustor are passes through a cleanup systems before being expanded in the gas turbine, and the exhaust gases are then passed through a heat exchanger which heats the feed water before being discharged. And finally, the temperature of the PFBC is limited to about 800 degrees Celsius. Because of this, this is the most favorable temperature of sulfur retention and is below the ash fusion temperature of coal. Right? In case of integrated gasification combined cycle, I mean IGCC, the coal is gasified either partially or fully, and the gas produced after cleanup is burnt in the combustion chamber of gas turbine. It is called an integrated gas combined combined cycle. Okay, IGCC. Actually, coal and limestone are fed to the pressure vessel, the coal being gasified by oxygen and steam, and the ash and the limestone form a slag which is discharged, and the gas is cooled. Okay, this gas is cooled. Here, the use of air instead of oxygen produces a gas of lower calorific values, and the exhaust gases from the gas turbine rises steam in the HRSG. The thermodynamic performance of IGCC power plants shows that there is an optimum pressure ratio of for a gas cycle at given temperature ratio T3 by T0 for maximum cycle efficiency. So here you can see the yes. So here I have shown the IGCC projects at Florida. Here the maximum output will be 250 megavolt, and so here it is in Indiana in 1995. There is a Wabash River. In Wabash River, there is a IGCC projects will be there, and that output will be 262 megawatt. Right. So this is a types of gasifier which I have shown in the manufacturer name, um, right? In which you have gasifier type and application which I have been shown here, right? In cold water, slurry feed, oxygen blown, refractory lined gasifier as used in flips. An application will be wide range of coals and General Electric Energy GE. Actually, the gasifier type will be cold waters, slurry feed, and O2. Okay, O2 blow down and refractory lined gasifier as there. And here it is in applications will be bituminous coal, pet coke or a blend of pet coke with a low rank coal will be used in this, and Kellogg brown and root. Okay, KBR. Here the gasifier type will be the dry feed air blown transport reactor. It is an application for this gasifier is low rank coal. So this is a simple black diagram of IGCC plants. Here you can see the air circulated systems. These systems which consist of many components. Okay, here it is the radiant sine gas cooler. There is a heat recovery steam generator will be there. There is a gas turbine, gas turbine unit. Okay, this is a gas turbine unit will be there, right? So this is the steam turbine. Here we are going to using gas turbine as well as the steam turbine, which we are already discussed in the combined power cycles. With the thermal efficiency will be 50% for this IGCC power plants when using gas and steam. Here it is a gas, here it is a steam used for this IGCC power plants. The main process of IGCC is the solid coal is gasified to produce fine gas or synthetic gas. In synthetic gas is synthesized by gasifying coal in a closed pressurized reactor with a shortage of oxygen. The shortage of oxygen ensures that the coal is broken down by the heat and pressure as opposed to burning completely. Here I have shown the chemical reaction of the IGCC product. They mainly the heat from the production of syngas is used to produce steam from cooling water, which is then used for run the steam turbine for electricity productions. Here the syngas must go through the pre-combustion separation process to remove carbon dioxide and the other impurities to produce more purified fuels. There is a steps which will be necessary for separation of impurities in the IGCCs. Here the water shift reaction. The main thing is the water gas shift reaction, in which there is a reaction will be there. The reaction is occurs in the water gas shift reactor. CO plus H2O gives the CO2 plus H2. This produces a syngas with a higher composition of hydrogen fuels, which is more efficient for burning later in combustions. The physical separation process is can be done through the various mechanisms such as absorption or membrane and separations and drying, compression and storage, shipping. The resulting syngas fuels as a combustion turbine that produces electricity. At this stage, the syngas fairly pure H2. The advantage and disadvantage of IGCCs. IGCC plants are advantage in comparison to conventional coal power plants due to their high thermal efficiency, low non-carbon greenhouse gas emissions, and capability to produce low-grade free coal. Okay, and the main disadvantage of these systems is higher capital and maintenance cost, and the amount of CO2 released without pre-combustion temperature. These are the main disadvantage of the systems.